There's an object out there right now, ancient alien visitor, that's racing toward our sun. For weeks, the world's most powerful telescopes have locked onto this strange light in the sky, hoping to uncover its secrets. But instead of answers, every new observation has only deepened the mystery. And now, time is running out. Soon, the object will slip behind the blinding glare of the sun, vanishing from our view, leaving us with a puzzle we might not be able to solve. So, what exactly is this thing? Officially, astronomers have named it 3I-ATLAS. That stands for Third Interstellar Object, a label that already sets it apart. Interstellar means it doesn't belong here. It's not from our solar system. It came from the depths of the Milky Way, one of those distant star systems scattered across the night sky. Which one? We can't say for sure, but evidence suggests this traveler comes from an ancient system. It's possibly twice as old as our own sun. And it's only the third time in history we've ever detected something like this. The first, of course, was ʻOumuamua in 2017. Long, cigar-shaped rock tumbling end over end, unlike anything we had seen before. To this day, scientists argue about what it really was. It's a shard of an alien planet, a bizarre hydrogen iceberg, or as some suggested, maybe even a probe. We may never know. Then came to Borisov in 2019, the so-called middle child of interstellar objects. It behaved like a textbook comet, growing a bright coma and tail as it neared the sun. Fascinating, yes, but also familiar. It reminded us that not all interstellar visitors are mysterious. Some are just comets. But now, 3I Atlas has arrived, and this one may be the strangest of them all. Already it's behaving in ways that defy our expectations. And as always in space science, the more data we collect, the stranger it gets. The first official detection happened on July 1st, 2025, when NASA's Asteroid Terrestrial Impact Last Alert System, or ATLAS, flagged the object between the orbits of Jupiter and Mars. But that wasn't actually the first sighting. Later analysis revealed that TESS, the Transiting Exoplanet Survey satellite, had captured an image of it weeks earlier, on May 7, 2020, while searching for alien planets. TESS didn't recognize what it was seeing at the time, but that photo placed 3I Atlas still out beyond Jupiter, closer to Saturn. That detail told astronomers something incredible, just how fast this thing is moving. For comparison, NASA's legendary Voyager probes, the fastest human-made objects ever launched directly toward Jupiter, took nearly 2 years to get there. But in just a matter of months, 3I ATLAS is sped from Saturn's orbit, past Jupiter, and into the inner solar system. By October 29, 2025, it will make its closest approach to the sun. By next spring, it will already be headed back out near Jupiter again. This kind of rapid flyby is the hallmark of an interstellar trajectory. The object is moving far too fast to be captured by the sun's gravity. Instead of looping into an orbit like a comet or asteroid, it will slingshot through once and never return. Now, here's where it gets weird. Even when it was still beyond Jupiter, 3I Atlas was bright. Very bright. That was puzzling. Because comets, our usual icy wanderers, don't typically light up until they reach much closer to the sun. Normally, their frozen water begins to sublimate, turn directly from ice to gas. Once they cross into the warmer region of the solar system, closer to the asteroid belt, that sublimation creates the coma, the glowing halo that makes comets so spectacular. When TESS first spotted 3I Atlas in May, it was still out in the cold zone. Yet the object was already shining and growing brighter every day. That means sublimation had already begun far earlier than expected. If 3I Atlas is a comet, then it's not like any comet we've ever studied. And if that wasn't odd enough, the mystery deepened as the object drew nearer. By July and August, 3I Atlas developed a tail-normal comet behavior. But instead of streaming away from the sun, like every comet tail we've ever seen, this one appeared to be pointing toward the sun. Think about that. The sun constantly blows a stream of charged particles outward in every direction. This is the solar wind, and it acts like a giant fan. When a comet approaches, the solar wind pushes its gas and dust away, forming a tail pointing opposite the sun. That's why comet tails always look like they're blowing backward. So when astronomers observed a tail growing in the wrong direction, the sun, it didn't make any sense. Imagine a dog leaning out a car window. Instead of its ears flapping backward in the wind, they somehow flapped forward. That's how bizarre this looked to scientists. And naturally, the world's most powerful telescopes were turned on 3I Atlas. NASA deployed the Hubble Space Telescope, the cutting-edge James Webb Space Telescope, and the specialized Spherics Observatory. TESS was also reassigned for a second look. Everyone wanted answers. And they got some, but with those answers came even more questions. Webb's instruments revealed that the coma surrounding 3I Atlas was made primarily of carbon dioxide and not water vapor. As we'd expect, as there was some water present. But the ratio of CO to HO was extreme, about 8:1. That's 16 times more CO than a typical comet. In other words, this object is made of the wrong stuff. It's alien not in the science fiction sense, but literally foreign to the way objects in our solar system are composed. Even more surprising was the scale. The CO coma was massive, expanding outward, with a radius up to 300,000 kilometers, nearly half the size of the Sun itself. If that's the case, the nucleus at the heart of 3I Atlas might also be much bigger than originally thought. Early estimates suggested a core 10 to 20 kilometers across. Newer models place it closer to 40 or even 50 kilometers wide. It is not unprecedented there. Our comet's over 100 kilometers across. In our own solar system, but combined with its composition, it makes 3I Atlas unlike anything we've cataloged before. And then came the strangest discovery yet. During observations with the Very Large Telescope in Chile, scientists detected nickel metal in the coma. But here's the catch. There was no iron. That should be impossible. Nickel and iron are cosmic companions, forged together in the cores of exploding stars and found everywhere in asteroids, moons, and planetary crusts. You don't find nickel without iron on, unless something has artificially separated them. That's when speculation took a wilder turn. Could this be an engineered object? Could some advanced civilization have created this in an industrial process? It's probably not aliens, probably. But no one can completely rule it out. Let's pause here. When astronomers talk about aliens, they don't mean little green men waving at us from a spaceship. What they mean is that the behavior of 3I Atlas.Untold fully match anything we've seen in nature before. And whenever that happens, speculation naturally expands into what-if territory. Some theorists suggested that the unusual brightness of 3I Atlas, its glowing halo forming so far beyond Jupiter, might not just be sublimation. Maybe, they speculated, it was an artificial signal. Think of a spacecraft turning on its lights. Could this be a beacon? A probe announcing itself as it enters a new solar system? Another idea that circulated online was even stranger. That the massive cloud of CO surrounding the object wasn't just venting gases from frozen ice, but could actually be life support exhaust. What if 3I Atlas is a kind of alien ark, carrying organisms that breathe out CO just like we exhale it here on Earth? In this view, the gas cloud could be waste, vented into space as the ship cruises through the solar system. And the boldest theory of all, the object itself might be a living organism, a cosmic creature that consumes interstellar gas and dust as it travels, metabolizing material and releasing CO as a byproduct, just like a whale filtering plankton in the ocean, except on a scale that spans hundreds of kilometers. Now, are these theories likely? No. But the fascinating part is that right now, no one can say with absolute certainty that they're impossible either. That's what keeps the conversation so captivating. Meanwhile, the practical side of astronomy kept pushing forward. Scientists knew they had a narrow window of time to study 3I Atlas before it vanished behind the no sun in late October 2025. That meant pointing every available tool at it while they still could. The European Space Agency got involved too, tasking their Mars-based spacecraft with an unusual side mission. In early October, when 3I Atlas makes its closest approach to Mars, passing within about 28 million kilometers to orbiters will be watching Mars Express and the ExoMars Trace Gas Orbiter. Their cameras and imaging spectrometers should capture valuable data about the structure of the coma and, crucially, maybe a faint outline of whatever solid body lurks at its core. Will it look like a cometary nucleus, rough and icy? Or will it show something geometric, something artificial? The images likely won't be sharp enough to reveal every detail, but even a blurry shape could spark new debates. Unfortunately, after October, Earth won't have a clear line of sight. 3-1 Atlas will slip behind the sun, hidden from our telescopes until December. When it reemerges, it will already be on its way out, fading back into interstellar space. But there's still one more potential chance to get close. On March 16, 2026, 3 IATLAs will pass near Jupiter again, about 53 million kilometers away. That's far still more than 100 times the distance from Earth to the Moon, but it just so happens that NASA has a spacecraft already in orbit around Jupiter. Juno. Juno was launched back in 2011 and has been orbiting Jupiter since 2016, studying its atmosphere, its massive storms, and its mysterious magnetic field. By 2025, Juno was nearing the end of its planned mission. NASA had intended to deliberately crash the spacecraft into Jupiter's atmosphere in late 2025 to prevent any chance of contaminating its moons. But now, with 3 IATLAs on its way, some scientists are floating an alternate idea. What if Juno's final act isn't diving into Jupiter, but chasing down this interstellar visitor? Even a distant flyby snapping a few images, measuring radiation, sampling particles in the coma would be revolutionary. Picture it. Humanity's first spacecraft intercept with an interstellar object. That alone would be historic. Now, let's rewind to the nickel discovery for a moment, because this is where things get especially strange. The Very Large Telescope in Chile picked up clear spectral lines of nickel gas in the coma. That means nickel was being vaporized and carried outward into the cloud. But there was no trace of iron. Here's why that's bizarre. Nickel and iron are cosmically inseparable. They're forged together in supernova, they condense together in planetary cores, and they're mined together from asteroids. Every natural body we've ever studied that has nickel also has iron. The ratio might vary, but iron is always there. So why not here? One possibility is that 3 IATLA is formed in a star system with wildly different chemistry than our Zan environment, where nickel was abundant but iron was scarce. That alone would make it alien in the truest sense, a relic of a world shaped by rules unlike the ones we know. But there's another possibility, the one that captures the imagination. Maybe the nickel was separated on purpose. Here on Earth, humans refine nickel and iron for industrial use, nickel for batteries, steel alloys, spacecraft parts. If astronomers are detecting pure nickel venting into space, could it mean this object once underwent an industrial process? That line of thought is why whispers of alien technology keep surfacing. Of course, mainstream scientists remain cautious. Most say there's probably a natural explanation we haven't considered yet. But even the most skeptical voices admit 3I Atlas is testing the limits of what we understand about comets, asteroids, and planetary chemistry. And that's why the stakes are so high. With only a short window before the object slips away forever, telescopes across the world and in orbit are racing to gather data. The James Webb Space Telescope is analyzing the chemical makeup of the coma. Hubble is measuring brightness and structure. Mars-based orbiters are preparing for their October flyby. And researchers are lobbying to extend Juno's mission in hopes of a 2026 intercept. If all goes well, we'll have a mosaic of data, spectral fingerprints, chemical ratios, brightness curves, and maybe even a rough silhouette of the nucleus. Put together, these could tell us whether 3I Atlas is just an exotic comet or something much more unusual. The truth is, though we already know it's extraordinary, its sheer speed confirms it's interstellar. Its CO-dominated composition is unlike anything in our solar system. Its backward-pointing tail defies simple explanation. And its strange abundance of nickel without iron challenges the most basic rules of cosmic chemistry. So, is it natural, artificial, alive? The only certainty is that 3 IATLAS is forcing us to expand our imagination and fast. Because by the time it disappears behind the sun in October, our best chance at solving the mystery may already be gone. This is an actual photograph of the comet that has left many scientists baffled. It is 3 IATLAS, a visitor from another star system, and it is hurtling towards Earth at a speed of over 240,000 miles per hour. But there is one thing that no one can explain. Why did it suddenly stop? Welcome back, everyone. In this video, we will be discussing the mystery of 3I-ATLAs. Why did it stop just 11 days after being discovered? What is it still up in space? What are scientists saying about it? And what does NASA have planned? So make sure to watch the whole video so you don't miss out on anything. But before we begin, be sure to click the subscribe button for more videos like this one. Also, stick around until the end because I have a surprise for you. Let's start with the October 2025 crisis. On October 2025, Comet 3I-ATLAS will disappear behind the Sun, leaving Earth's most powerful telescopes in the dark. This includes Hubble and the James Webb Telescope. As a result, astronomers will lose sight of the comet for several months, which has raised concerns about our ability to track its path and predict its behavior. However, ESA has found a solution to this problem. Mars Flyby Opportunity. According to the European Space Agency, their Mars Express and ExoMars orbiters will pass near the Sun during their orbit. And during that time, they will be humanity's only eyes on the mysterious object. They will try to determine its characteristics, such as its size, shape, composition, and brightness. But why is this comet so interesting? What makes it different from others? And why are scientists so concerned about its sudden stop? Let's find out. First off, the comet's trajectory is hyperbolic, meaning it doesn't revolve around the Sun like most comets do. Instead, it flies by the Sun once and then leaves the solar system forever. This suggests that the comet's path is influenced by forces outside the Sun's gravitational pull, which raises questions about where it came from and how it got here. Secondly, it's brighter than expected. Usually, comets are only visible with a telescope and become fainter as they approach the Sun. But 3I Atlas remains bright even as it approaches the Sun, which is unusual and challenging for telescopes to observe directly. Thirdly, its tail behaves strangely. While most comets have tails that stream behind them, 3I-ATLAS's tail appears fragmented and changes direction. This could be due to the interaction between the Sun's radiation and the comet's dust and gas, but further observation is needed to confirm this theory. And finally, its composition is unusual. Comets are typically made up of ice, dust, and rock, but 3I-ATLAS seems to contain more carbon dioxide than expected. This suggests that the comet may have originated from a warmer region of its parent star system, which challenges our understanding of how comets form and evolve. These unprecedented characteristics have made studying Comet 3I Atlas both challenging and exciting for astronomers. The mission will shed light on previously unexplored aspects of cometary science and could potentially revolutionize our understanding of these icy visitors from the distant reaches of our solar system. Now let's talk about Juno's final mission. After exploring Jupiter for nearly a decade, NASA is considering giving the probe a new mission to intercept the comet. On March 26, 2026, the Juno spacecraft is expected to reach a critical point in its mission, when it will come within 900 miles of the comet. If approved by NASA, the spacecraft will detach from the probe and use its remaining fuel to fly as close as possible to the comet. This would allow the spacecraft to take the first ever close-up images of the mysterious visitor and gather valuable scientific data about its composition and structure. However, the plan also poses a significant risk. Dedicating the spacecraft to this risky mission means giving up on any chance to study Jupiter's moon Europa, which scientists believe could harbor life-friendly environments beneath its icy surface. Furthermore, the plan comes with a high price tag, estimated to cost approximately $100 million. Despite these challenges, the proposed mission represents an exciting opportunity to learn more about the origins of comets and the building blocks of our solar system by sending a spacecraft to intercept Comet 3I-ATLAS. Scientists hope to gain insights into the chemical activity on the comet and the conditions under which it formed. Such knowledge could help answer fundamental questions about the evolution of our solar system and the possibility of life elsewhere in the universe. Now, you might be wondering, what is so special about this comet? Why are scientists going to such great lengths to study it? Well, it turns out that the comet holds some unique characteristics that make it a prime target for scientific investigation. First and foremost, its origin. Scientists believe that 3I-ATLAS hails from a completely different star system. This means that it carries with it material that has not been tainted by the Sun's influence, making it a pristine sample of interstellar matter. Studying this material could provide invaluable insights into the conditions present in other star systems and the processes that occurred during planet formation. Moreover, the comet's unexpected behavior has piqued scientists' curiosity. Its hyperbolic trajectory suggests that it has been in the solar system for only a short period, possibly just a few years. This raises questions about its long-term stability and the factors that could have caused its sudden appearance. Additionally, the comet's unusual composition and brightness challenge existing theories about comet formation and evolution. Its high carbon dioxide content, for example, suggests that it originated from a warmer region of its host star system, which contradicts the traditional view that comets form in the cold outer regions of planetary systems. By unraveling the secrets of 3I-Atlas's composition, scientists hope to gain a better understanding of the diverse range of materials present in the early solar system and the processes that shaped them. In conclusion, Comet 3I-Atlas presents a unique opportunity for scientific discovery that should not be missed. By dedicating the Juno spacecraft to this mission, NASA can contribute to a deeper understanding of the chemical activity on the comet and the conditions under which it formed. The potential findings could revolutionize our knowledge of the solar system's evolution and the building blocks of planets. However, it's essential to acknowledge the risks and costs involved in this endeavor. Giving up on studying Jupiter's moon, Europa, and investing $100 million in a single mission are significant decisions that require careful consideration. Ultimately, the decision to proceed with the mission will depend on the scientific merit and feasibility of the proposed plan. If approved, the Intercept mission could provide an unprecedented opportunity to explore the origins of our solar system and the conditions present in distant star systems. The potential discoveries await as humanity takes another step toward unraveling the mysteries of the cosmos. Speaking of mysteries, did you know that each interstellar visitor, like ʻOumuamua, 2I Borisov, and now 3I, Atlas brings samples from alien star systems to our doorstep? True, these are not physical samples, but rather pieces of information encoded in their physical and chemical properties. When deciphered by advanced techniques, these clues reveal the composition of the stars and planets that birthed these wanderers and the environments they traversed before reaching our cosmic backyard. Now that's a legacy worth preserving. We want to send a message to those intrepid explorers of the past who set out on journeys that would take centuries to complete. We are ready to welcome you, not just as distant guests from faraway realms, but as messengers carrying vital information about your worlds. Your arrival is eagerly anticipated as it offers us a glimpse into the conditions that prevailed in the universe at the time of your departure. With each passing century, we stand ready to receive your stories from distant star systems. As we look to the future, see a path that leads to more cosmic visitors, and perhaps even the opportunity to intercept them directly. But this prospect requires preparation. Just as the legacy of past interstellar travelers guides us, so too must we lay the groundwork for those who come after us. Advancements in propulsion. Observation and data analysis will be crucial in ensuring that we are ready to receive the interstellar guests of tomorrow. We must invest in technologies that enable faster, more precise, and more comprehensive exploration of these celestial bodies. This journey is not just about satisfying our thirst for knowledge. It's about recognizing the profound significance of interstellar visitors. Their arrival challenges us to expand our understanding of the universe and the possibilities that lie within it. To ignore such opportunities would be a disservice to the generations that have looked up at the stars and dreamed of exploring the cosmos. Therefore, we call upon all nations, scientists, and space agencies to join us in this endeavor. Let us unite our resources, expertise, and imagination to prepare for the interstellar visitors that await us. As we reach out to welcome them, we must also strive to understand the worlds they come from and the journeys they have undertaken. By unraveling the secrets carried by these cosmic messengers, we can piece together the story of the universe and our place within it. Thank you for watching. Please share your thoughts in the comments section below. Your feedback is very important to us. And don't forget to hit the subscribe button for more amazing videos. Thanks for watching. See you next time.